It's certainly a pleasure to be here today. I said this yesterday, but it's 41C where I live, so it's absolutely wonderful to be in cool, even though it's damp Norway. Okay, so it's count your blessings one way or the other. I'm really glad I'm here, and thank you all for coming today. I have to give credit where credit is due. I attended a presentation by ACGIH and AIHA in April of this year in my home state, and they took all day to talk about occupational exposure limits and how to set them. So you're getting all of that condensed into about an hour. That can be good and that can be bad. So we're gonna move through a lot of information. But now I'll introduce myself. I'm Jennifer Galvin. I'm a board-certified toxicologist and a certified industrial hygienist, and I am retired. Retired as from ConocoPhillips as the occupational health manager. And it is important, I think, in this setting for you to also know that I'm a former employee of the U.S. Occupational Safety and Health Administration, because later when I start talking about the setting of PELs, permissible exposure limits, which are the exposure limits set by OSHA, I know a lot about that, and it's unfortunate that it's not progressing, but we'll talk about that in a moment. But I did want to give credit to Jimmy Perkins. You may or may not know him. He's the past president of ACGIH, and Tracy Kimmel, who gave this presentation, a similar presentation, and she's a member of AIHA. So I wanted to make sure that they got credit. If they were to see this, they'd go, oh, I recognize that slide, and I've tried to give them credit. But we are going to talk about the basic process for OEL setting. And very briefly, as I've already alluded to, the U.S. OEL setting process, and a little bit about the EU OEL setting process. So I know I'm, as we say, preaching to the choir when I say these things, meaning there's a lot of challenges to setting OELs. There are thousands of chemicals in use and only hundreds of OELs. So that in itself, just the number of chemicals in industry or in use is a huge challenge. The amount of data that's available on each chemical or not available in many instances is a challenge. And then we could talk about whether what the quality of that data is, the reliability. We're not going to talk about that today, but that is another challenge. I think a challenge is that OELs are not well understood. And by the way, I think my audience knows OELs. I'm going to use that acronym for occupational exposure limits throughout this presentation. If I'm using an acronym that you don't understand, please ask me. But I don't think they're broadly understood. I don't think they're broadly understood by management. I think our workers may understand them better than many people. When you talk to a worker about an OEL, how that is a protective level, I think they understand that. But I don't think management within our corporations, I don't think governments yet understand how much resources are needed to focus on generate good OELs and really what the value that brings. So the last statement of OELs not being valued, I think, follows from them not being well understood. And certainly, I think the next slide will show, I don't think we have enough resources or expertise in that area. One slide is going to talk about the expertise that's needed, and I think those of you in the room and your understanding of how chemicals are used and toxicologists understanding the baseline data are the people who should be setting OELs. And I don't think there's near enough of us in the world. But I think everyone would agree that I'm not going to read these to you, but this is sort of the basic definition of what an OEL is. We do have sensitive subpopulations that are at least acknowledged in the second dot point, but the basis of an OEL is, in this case, in this definition, airborne concentrations of substances and conditions under which nearly all workers may be repeatedly exposed without adverse effects. And if anyone disagrees with that, we might ought to discuss that right now. Everyone knows there's a whole different array of OELs set by different countries, different agencies. Many industries set their own OELs for various reasons, some of which are easy to talk about because governments don't always act as quickly as we need for them. There's too many chemicals for them to act quickly. They don't know which ones are important to each individual industry. So many industries resort to setting their own OEL. And this is just a list. Lots of acronyms that I'm sure all of you've seen and know and understand. There are legal requirements out there. These are just two of many, but they're requirements to assess data and protect your workers. EU REACH, although that may be the most recent, but requires manufacturers to set derived no effect levels, or DNLs, or pseudo exposure limits for chemicals they sell. I'm going to talk about that in detail at the end. OSHA law explicitly states that it is the responsibility of the employer to provide a safe workplace. Did that say they have to assess data? No. And that is, I think, in many instances, part of the problem is that there is not an understanding through people who have never set these what is required to provide a safe workplace. In their minds, something they can see, like a scaffold, they can understand how you control, manage, and regulate that. For chemicals that you can't see, you can't smell, how do you regulate that? So we're really in a conundrum of understanding. People find it very difficult to understand things they can't see. We're also in a very technical field. So when we talk about all these acronyms of time-weighted averages, short-term exposure limits, people tend to just go do what you need to do. Don't bother me with the details. So I'm sure you've all experienced that at some time or another. The resources, this is what I was talking about earlier, that I think people can disagree with this as well. In fact, the two I've listed down here would probably disagree with me the most. But I think the resources that are needed to set OELs are primarily industrial hygienists and toxicologists. In certain instances, when you do have human data, epidemiologists can certainly be of value of interpreting that data. Unfortunately, we don't have a lot of epidemiology data. Occupational medicine experts can be helpful when you're setting biological exposure indices. Disagree if you like. Yes?
And also medical experts can provide good information if the OEL also needs some sort of medical surveillance. You're not needing that for the OEL itself, but
right. I wouldn't disagree with that. I would say they're needed on a different level from the OEL setting process. They can facilitate the implementation of the outcome of a BEI. But understanding the data that goes into setting the OEL, they're a second tier. Once again, you know, there may be people who watch this and disagree with me, or there may be people in the room who disagree. I still believe they're sort of a second tier expert. A lot of words on this slide. We're going to talk about each data point, some in more detail than others. But Quickly, I'll go over this and then I'll break it down and we'll talk about the needs of many of the data points. But you have a candidate chemical. So what do? Whoever you are, whether you're a supervisor on a platform or a lubricants plant mechanic, you say, hey, this is new stuff, whatever it is. I don't know how to protect myself or my employees against this. Hopefully that request finds its way to people who are setting OELs within that company, and they know. I snap my fingers because we know what to do. You collect the information, you collect the data from all sources. Certainly would like to have some human data. That's the best and most important. We'll talk about that in a minute. Identify the critical effect or the critical endpoint. That can be anything from liver damage to respiratory irritation. We'll talk more about, you certainly want to focus in on the most sensitive adverse effect that's relevant to humans. Then you have to define your reference level or point of departure. I'm going to talk a lot about that because that's real important to setting the OEL. So if you don't know what that is, don't worry about it, but you can be intuitive about that, which that is sort of the lowest data point where we have information. And as I say, we'll talk more about that. Dose that causes the critical effect, the NOEL or the LOEL. I'm going to define those for you in just a moment. And then you have to decide, what is the risk assessment methodology that I'm going to use, or am I going to use a risk assessment methodology to set an OEL? Then calculate your OEL. We're going to try to do all that this morning fairly quickly, so I'm going to get into this and try to spend time on what I consider the most important issues. Collect a complete data set. Most of us would go to the literature. That's what we do. In instances where I have a product that's new, you would suggest to that organization, you need to do testing. I don't have enough information to set an OEL. I can't even tell your customers or your workers how to protect themselves. So we hope we have some data and we don't have to start at that point because it's years to collect the data from the baseline, shall we say. That certainly incurs a lot of cost. A lot of people will start with in vitro cell culture type studies. That costs the least. It's quick. People gather that information, but it is probably the least important. Next, you would go to whole animal. That's more expensive, more relevant. You hope you have some of that information. And lastly, you would collect information on the human experience. But that, too, is the most expensive and takes the longest to gather. The risk assessment, of course, is for us humans, so that's the sort of information we need or information that is the most relevant to humans. I'd like to add sort of an aside here. I did my master's on hexavalent chromium, and what I did was compare in vivo cell culture methodology to whole animal. And what we found very quickly, and is very intuitive, is that the cell culture shows toxicity at very low concentrations, whereas the whole animal does not. And as you can imagine, you don't have to be an expert in cell culture, but you have a concentration of chemical that cannot move away from a critical target, can't be readily metabolized many times. My experiment was with pulmonary macrophages, and you can say, well, of course, that's true, that you would expect your whole animal experiments to show lower concentrations causing toxic effects. I'm sorry, I said that backwards. Taking more chemical to cause a toxic effect. My point being, if all you have is in vitro data, you have to set an OEL using that information. Or say, I need more data. So all I'm saying is you have to think about the type of data you have and and how it's going to impact your OEL. I could probably talk about that one slide all day, but I'll move on. Believe it or not, is the data you have or the endpoint you have, is it relevant to humans? Many of you in this room may know that about the kidney study, the kidney findings with gasoline many years ago in the early 90s. It showed that gasoline caused kidney tumors in rats, in only male rats. Well, what are we females going to do? We're okay. Guys have to stay in the car while we fuel our cars, but point was, additional research showed that there was a protein that accumulated in the male rat kidneys that wasn't relevant to humans, wasn't relevant to any other species. So you have to be very aware of, is the data I'm looking at relevant to humans? Route of exposure, is that relevant to occupational exposure? Toxicologist, I can apologize for the field all day, but many times the only route that we can use to do a test is drinking water. We hope our workers don't drink water that's contaminated with chemicals, but that may be the only information that you have to use to set an OEL. And actually, you can use that data, and I'll talk about that a little bit. Appropriate species and strain. Governments set up appropriate protocols. Rabbits are used for sensitization. What do you do if you have a rat study? A lot of information that I don't know that you've been exposed to, but you have to know and understand the data you're looking at, is my only point. Acceptable dose response with threshold. That, I'm going to talk a lot more about that right now. As the dose goes up, more animals respond to it. As the dose goes down, you see fewer and fewer animals that respond to the chemical exposure. That's as simple as I can get, and you think, yes, everyone knows and understands that. But sometimes you will get an effect that's reported only at the low dose, nothing at the high dose. What do you do with that? That's inverse toxicology. Do you use that data? What do you do with that low data point? So you have to understand that, once again, the data you're looking at has to follow sort of a pattern of acceptable scientific thought, or you have a problem. I said I was going to define these. I think I'm going to show you those definitions, and then we'll talk about it. This last data point is talking about whether you have data spread across concentrations with the bottom dose not showing any effect. That is sort of the paradigm across which toxicology works. And if you don't have that, you're trying to decide how you use that information. If you don't know what NOELs, no AELs, all that's sort of toxicology speak. NOELs is no observed effect level, none, zero. There's no liver enzyme increase. There's no matting of the eyes in the animals that are tested. There's no effect. Why would there be any other effect? No observed adverse effect level. If you get matting of the eyes, but no liver enzyme changes, then you can still use that information. We talk about that. We use that information to build confidence in the data that we're looking at. Lowest observed effect level. You don't have to, there won't be a test, by the way. You don't have to worry about these. I'm going to show you a slide that sort of helps define these. And then frank effect level. Everybody knows that animals' labored respiration is going to lead to death. That's a frank effect level. I put this, it's got lots of information on it, but hopefully to show you how we sort of think about that data. Right down here is no observed effect level, but you are starting to get some enzyme changes, probably in liver, maybe sometimes in the cardiac tissue. These are all blood tests. You're not actually looking at those tissues. You may even start to see a slight body weight decrease. The chemical is actually affecting the animal's ability to take in food or process the food, or they're just not hungry, whatever. This is a no observed adverse effect level until you get way over here. You're starting to see fat increasing in the liver, like carbon tetrachloride. Very low levels, you may see a little bit of it. It's not harmful to the animal, especially if the exposure is ceased or stopped. But if you, like many things in life, if you keep up a bad behavior, then you're going to start to see a critical effect, but it's a much higher concentration. Now I'm going to talk about the methodology. Sorry to spend so much time on that. You're probably more interested in this methodology and not so much in the data and how toxicologists at least think about it. I am not going to talk about correlation, just the other three. You may say, well, do I have to pick one? The short answer is you don't have to pick a methodology. In fact, you're probably going to use all three. If you ever set an OEL, you'll probably use all three. Let's talk about analogy. One you'll have an example here of one you'll understand. You have an incomplete, I know you'll understand it, but recognizing it right off, you will do that as well. Incomplete data set. I'm gonna jump to this slide so you know what I'm talking about. Let's say you have a chemical that looks like one of these. Which one of these do you pick by analogy to set your OEL? Do you say, well, it looks more like benzene? Well, the simple question would be, does it have any, I'm sorry, I'm pointing at my slide here, or my computer, like you can see that. Does it have any groups hanging off of it that look like any of these others? Analogy is just taking a chemical structure and saying, I don't have any data on this, but the folks in the field are being exposed, so how do I set an OEL? You take a very similar chemical structure and you basically say, it has two methyl groups, therefore I'm going to use toluene. Now, you have to decide yourself if that's defensible. Now, some of you may say, Jennifer, do you know what that chemical is you just described? Yes, I do. But for example, what if you don't have data on that? What do? Well, you would look at this and pick one out and then increase probably a safety factor. We'll talk about that in a minute. So hopefully I just described this in words or by example. You take an OEL that is set based on lots of data. We always like lots of data. And try to come up with a homologous chemical and use data from chemical A to set your OEL for chemical B. And of course that's based on this assumption that the toxicity is similar. And I've put there not always a valid assumption, because if you said, phenol is similar to benzene, and I'll just ignore that hydroxyl group, the OH, you'd come up with a TLV 10 times lower than is currently set. So you do have to be careful when you use analogy, but there is a way to add comfort to your decision, which is to increase the safety factors. And a safety factor, and you get to choose that as well. Are you really uncomfortable? Divide your OEL by 10 instead of 5 or 2. And hopefully you're getting the sense this is not an exact science. And I think that's why so many people are frustrated. Certainly in recent years, ACGIH levels, they've been sued over those levels. There's always an opinion. And you get to decide internally if you're setting an OEL, how do you set it? Where do you set it? How do you justify that decision? And it's not easy. Low-dose extrapolation. I was talking about those data points as time has moved along and experimental design has improved, where you have multiple concentrations that you're dosing animals with. You get to see, I have a whole range of data points. The lowest one shows no effect. The top two do. I feel pretty comfortable that at least with the animal data that there's no effect at 400 parts per million. Pick a number. It's just an example. The simplest case is you can draw linear extrapolation. I believe I have an example of that also. So here's your last dose, and you say, what happens down in here? I can draw a straight line. That's very conservative. Let me explain what I'm talking about. If you have an effect and a response right here, you're not going to set that as an OEL for humans. You're going to set it somewhere down in here. Well, how you draw this curve is very important as to what number you pick. That's why this is important. So do you pick this number? Do you pick this number? Do you pick this number? And you can see what broad range of doses for an OEL you would have. So this is really important. Our government, EPA, not OSHA, tends to draw a straight line and say this is our expected dose response. And this is fairly conservative but very protective. Once again, you get to decide how to draw this line. If you have data that indicates it's like this, there's not too many of those cases, but then you can pick a dose that is very close to this effect level. I personally don't recommend that. Don't ask me why. I'd rather err on the side of being more protective than less protective. I'd have to have really good data to select this dose. What is conventional thinking in toxicology is that, and is not displayed here, is that you have a curve that looks like this, or we call it the S-shaped curve, where you and I can be exposed to chemicals at low doses because our bodies can metabolize it, they can excrete it, they can exhale it, they deal with it, they manage it until it reaches a critical concentration and overloads all those mechanisms. And then you start to show toxic effects. This is just an example, but I think I've said all that with that example. This is probably the most common way to set an OEL, is the margin of safety approach. And I think I sort of described that to you earlier, is I'd have to have really good data to set an OEL close to a dose where I've seen effects in animals. I would say, I want a little bigger margin of safety there. Gosh, I've been in the field probably 30 years. I've never seen a data set so well defined where I would pick an OEL close to a dose where I saw effects in animals. Never. Not once. And so I wanted you to know that the smiles and the body languages, I couldn't do that. I've never seen a data set that was that perfect. But margin of safety, I like, because I'm laughing because it's like, it's not scientific in many respects, but you sleep well at night. What do I mean by that? Once again, it gets back to these are animals. They're not totally like us, So how do I provide that cushion to assure myself that I'm not harming workers' health? To talk about, I say there's no science, and then yet we're going to talk about what little we do know and can do by setting a smart margin of safety. I keep talking about identify the critical endpoint. Once again, is it respiratory irritation? Is it liver damage? What is your critical endpoint? Then you have to define, okay, I know that at 2 ppm I get respiratory irritation. So where below 2 ppm do I not get respiratory irritation? So define the no effect level. And what is it that makes you feel uncertain about that data? Is it because it's in animals? Is it because it was a short-term study and I know my workers are exposed every day for years on end, and this data point was collected in a 6-month study or a 3-month study? You really need to sit down and document what is making you uncomfortable about this OEL. And we're actually I'm going to show you how to do this, calculate an acceptable, hang on Tron just a second, calculate an acceptable daily intake, and from that you can calculate your OEL. Yes, sir.
What I don't understand is that ACGIA recently has used people that already have a disease, people with asthma, they expose them to sulfur dioxide to see what levels they got sick on. Is that common now to use people that are already sensitized, already have a disease, when they are setting an OEL?
That's not common. That is a departure from the way ACGIH has set TLVs in the past. I don't quite understand what Tron is talking about. SO2 there was recently a TLV published at 0.2 parts per million as a short term. I don't recall all the details, but what the TLV was set on was non-medicated exercising asthmatics. The reason I have such an issue with that is I can't control whether the asthmatic takes his medicine or not. Asthmatics are not always documented in the workplace, so I can't even ask that person or tell that person, you shouldn't work in our SO2 unit or around our... So I can see... I just can't understand why ACGIH did that. I can see them even putting a warning around a TLV saying, please be aware for the IHs in the world to be aware that this occurs. But to set a TLV using that type of data is a mystery to me. It's a departure from normal. Yes.
We have some larger and larger subgroup in the population of people with certain diseases, and those should also be protected. The amount of asthmatics increase, the amount of diabetics increase, and they should also be allowed at the workplace.
I'm not saying that at all, and I'm not saying they shouldn't be protected. I'm saying, do you want me to invade your personal space and say, because you're a diabetic, I can't let you work there? I don't know who's diabetic in my workplace. And that's why there is this responsibility, but where does the line lay? Is it my responsibility to list all of your medical conditions? You're diabetic, you're asthmatic, and you have high blood pressure. You can't work there and there and there.
The alternative is to do what they have done. To use them as a test population and see what can we expose say?
Well, then they would have to, in my opinion, then they need to test diabetics.
And other
Mm-hmm.
large
Mm-hmm.
populations.
I'm saying that the employee has to take some responsibility. If they're unmedicated asthmatics, why are they unmedicated? It is, our job is always, as this is an American opinion, maybe a Jennifer Galvin opinion, we as employees have to take some responsibility. We are not robots. I don't wait for people to tell me to put on my seatbelt. I take care of myself when I have that information to do so. That's why I'm saying educate, but educate your workers on this fact, but don't set a level on that fact. Remember that first or second slide was nearly all employees are protected. I think it's a great debate to have, but it's a decision that needs to be made and not just a TLV set, because to me that's a real point of departure. They're going down a road now that they'll never have all the data, meaning they're not going to have data on as diabetics or arthritis or liver disease. So where do they draw the line? I think they communicate, but they don't try to protect absolutely every disease that people might have. I don't know how they will do that.
No, but it's an interesting discussion.
It is, indeed.
And should you protect all, or should you say, okay, at least 75 or 80% of the population, and if 30% is asthmatics, or it's not that bad, then you have to include them.
Mm-hmm. Mm-hmm. And that's why I'm saying if SO2 is especially problematic for asthmatics, then maybe they send that flag, but they don't set the level on that. Set the acceptable exposure level on that. We won't solve it here. It's an interesting discussion to have. Before I get into safety and uncertainty factors, I want you to know that what I have presented today is, or will be presenting today, is much like DNLs. And what do I mean by that? I am going to talk about DNLs in a moment, but this way of setting OELs is very conservative and allows you to drive the OEL to an extremely low level that would be protective of every person in the workplace. And you can decide, once again, how conservative you can be. There is some science behind this, where those uncertainty factors should be set. We can talk about those at a later time, but ACGIH, my understanding is that they've had some real discussions around how conservative do they want to be. In the U.S., the EPA uses this very process for setting exposure levels to the general population. And there is discussion around why should our workers be differently protected than our general population. So there's lots of conversations to have. And you say, well, obviously workers are either work 12 hours or 8 hours, then they're off, the exposure ceases. But there's a whole discussion raging around how conservative to be here. Okay, I'm going to start right here at the OEL. I'm going to talk about the reference level being your last point from which you have data on that graph that I showed you. From there, you have to decide, is this, I'm going to jump around here a bit because this, I think, is the way my brain works, but is this chemical a sensitizer? I can tell you from experience that if you have a sensitizer, you probably should be fairly conservative. People don't react in a dose-response manner to sensitizers. And if you have experience with the isocyanates, trying to think, they just don't react the way you expect them to. You don't increase the level and then you have 5 respond and then increase the level and then have 8. You may have people who are exquisitely sensitive to certain chemicals. So if the chemical you are trying to set an OEL for is a sensitizer, be very careful. Think about that data quite a bit. Does it accumulate over time? How often are these people exposed? Make sure, once again, that you look at that and consider possibly dropping the OEL if it's a bioaccumulative chemical. And the way you drop that OEL is by increasing this modifying factor. You can see it's in the denominator. So if you make that 10 instead of 3, you're going to drop your OEL. This is pretty well set, as I'll show you in the example. This is one that is always a fun one to debate. EPA says, just use one. Everything is 100% bioavailable. If you look at the data, that's not true. It actually is there. You can find it, and you can actually put in only 30% is bioavailable if you choose. Just depends on how in depth and involved you want your OEL to be. I'm going to show you quickly. I think this slide says a lot. Many times people want to say that an OEL is a bright line, and if you exceed that, you can expect to get adverse effects. You and I know that's not true. We're going to protect our employees, and you're going to have a margin of safety around that OEL. But where is the line where you get frank effects? We don't know exactly. We don't want to find that. So we set an OEL that is safe for nearly all employees. And I'm sorry, you see down here, as dose increases, we get more and more uncertain as to where the toxic effects will occur in different people. I just wanted to list this. We had started out talking about sources of uncertainty. There's many. There's probably more than are on this slide. They're actually fairly important. There is some science behind which numbers to use. For interspecies extrapolation, do you use body surface area? Do you use respiratory rate? What do you use? Mice breathe really, really rapidly. How do we compare that to humans? I'm not trying to give you every piece of information you need today to set an OEL, but please know there is some science around each one of these. Lowest observed adverse effect to no observed adverse effect extrapolation. In other words, if you have this and you want to assure yourself that you will have a no observed adverse effect level, what number do you use? There's been people who've gone out and evaluated that. McAllister, I think, published that back in the early 90s, that dividing a number by 3 is conservative enough. Subchronic to chronic, I've already mentioned that. You have a 6-month study and you know your workers are exposed to this 8 hours a day for years and years. How do you deal with that? I said we'd talk about, hey, how about drinking water? How do you use that information if it's the only piece of information you have? There is science behind how you do that, use that data. And a lot of that circles around how well is it absorbed. I really don't like to do that, but you can if you have to. Database quality and completeness. As a toxicologist, I can give you a list of studies I'd like to have in order to set an OEL. Do you have 2 of those? Do you have 10 of those? Do you have all of those? And how good is the data that you have? Pretty boring stuff. That's what we get paid to worry about. And then talk about a little bit more about modifying factors in just a moment. Wanted to give you an example. Say you have a reference level of 30 milligrams where you saw an effect, and you have several factors that, sorry, I keep pointing at my computer. It's as simple as this. You can do the calculation like this. This is usually the most conservative way that you can calculate an OEL. Okay? It uses all the data that you might have, usually animal data. These vary based on data quality. As I said, a lot of studies were done. I mean, a statistician just looked at studies and said 3 will take care of a modifying factor here. I can tell you that is rarely used. You rarely see a 1. That's usually a 10. And once again, what it's doing is driving your OEL lower. And you will see people go back and say, oh, 0.02 I think is unrealistic. I'm going to go back and study each one of these and see where I can make the number lower. I'm sorry, make my modifying factor lower so that my OEL will actually come up. And you say, oh, that's cheating. You can't do that. It's a lot of professional judgment. A lot of professional judgment. Really haven't even talked about how you set a TWA versus a STEL versus a ceiling. I've just given some quick examples here. I'm sure I don't know how much time I've used, or I'm not sure you told me how much time I could have, but I'm sure you're getting the overall picture, though, that setting these should not be done lightly. They're not easy. They do involve a lot of professional judgment. So all of you know TWA is repeated exposure day after day. That may, your thinking should change if you're worried about irritation or chronic or irreversible tissue damage or causing significant narcosis. You'd use a STEL then, and the data changes. I'm not going to go into that too much. Skin notation. I think this is probably one of the most discussed, underappreciated, under-addressed areas. Lots of workers get chemicals on them, and this is really not addressed very well. ACGIH does set a skin notation, but it's all sort of wound into a TWA or a STEL or a ceiling. These are just definitional. Most of, I'm sure all of you know about why a skin notation is set. I don't think this data is very well handled or certainly not very well defined. It's for the most part done in animals. There are some human skin models out there. But that data is just coming into existence. A skin notation may not be appropriate when the substance causes skin irritation. Even though it's well absorbed, you don't want to, you protect the worker. You don't say, oh, yes, well, I'm going to consider that in my TWA. No, you don't. You just protect your workers against it. So you don't set a notation. You protect. You don't worry about a skin notation if it's readily absorbed but doesn't cause any systemic toxicity. DMSO being probably the best example. Dimethyl sulfoxide. They used to, still do, I think, put drugs dissolved in DMSO and spray it on the skin of infants so that the drug itself is absorbed. But the DMSO itself is, even though it's well absorbed, doesn't produce any toxicity. Once again, you have to think about the data. I'm really, this is just definition when you would consider it, when you would consider setting a skin notation, and at what levels. Obviously, I want to get to the OEL setting process in the U.S. and the EU, and finish up and see if there's any questions. Today's U.S. Permissible exposure limit process, in my opinion, has ground to a halt. We have not had a new PEL since chromium in 2004, something like that. It took at least 10 years to set that PEL. The courts had to go in and tell them to set, and gave them a deadline when to set that PEL. 6B rulemaking is just the legal term for setting a PEL. It is chemical by chemical specific. What happened in 1992 was OSHA said, okay, we know our PELs are out of date. They actually started this process back in the late 80s, early 90s. We're just going to go out and adopt ACGIH's TLVs. Court said, nope, you can't do that because there is no legal process by which you can do that. 6B, which is part of the law, says you got to do it one at a time. So in 92, they kicked out all of the most recent TLVs. And since that time point, I think OSHA has published maybe 2, maybe 3 PELs. Butadiene came after that, and chromium. So it's sad. I don't believe anybody is happy with the process. I don't think the unions, industry, and certainly not the government are happy with that process, and no one is finding a way through the morass. And it's really sad because I think the workers are the ones who are suffering. And when I say suffering, I mean we don't have guidance, so we do it piecemeal, industry by industry. Saying that, I hope I don't offend anyone by saying I don't think the EU is in a whole lot better shape. If you're shooting, I can duck, but if you were setting them, I can tell you that U.S. companies would be adopting them because everyone is looking for guidance. They're saying, just, give me something and then back it up with some data, but I need something. So years ago, I think even prior to the EU coming together as this union, a lot of countries started with the ACGIH's TLVs, but as I state here, I think this is more in the past, not so much now. You certainly had your individual country efforts in the German max and the UK KOSH. Now you have the EU SCOLs, and my understanding is they're recommendations. No one member state has to adopt them. They're recommendations. I don't know how many of those come out in a regular way. Not many. I can tell you because of some work and a reason I was here yesterday, had a chance to talk with Helmut Grime, who's chaired the German MAC Commission for years, and he said, there's no understanding, there's no value, so I'm always pressing for, I don't have enough people. And in the U.S., it's like a volunteer process right now with ACGIH. They're all volunteers. I mean, they have a small office staff that get paid, but the people who set the TLVs are all volunteers. The American Industrial Hygiene Association is exactly the same way. They're all volunteers who come together. They have day jobs. They probably have families and night jobs. But I don't see any cohesive process that is routinely evaluating chemicals to set occupational exposure limits anywhere in the globe. Some people said, oh, well, REACH is going to require us to do that. They're setting DNLs. As you know, I think, well, there's worker, consumer, commercial. They're having you look at all these risks. And the one worker risk that they evaluate is inhalation. But they're doing that in a very conservative method. I needed to have figured out how I was going to relate that back, but the EPA method for setting community exposures and DNLs, where they consider all these exposures together, it's a very conservative exposure limit that they're setting in REACH. It would take a lot of discussion before I would say, yep, we need to pluck that out of the REACH process and use it as an OEL. I really don't think that they intended those to be OELs. I think they intended us to keep our OELs that were set by member states and use those. Those were being used to address risk and how you put in place measures to reduce the risk. That's I don't like the way I even said that, but because certainly as an industrial hygienist we address risks and exposures. Yeah. This is what I'm saying without moving my slides along, but I'm very near the end, and I think there are lots of processes. I've said lack of the right resources. I would also say just generally lack of trained resources. And I'm saying that because do all of you want to write an OEL and bring it back to this group and let everyone review it and give input? And then, I mean, it's a very laborious process. And when you have other responsibilities, it's very difficult to get that done. Conversations that need to be had. What is acceptable risk? Discussions were had in the U.S. about, well, we need to go to zero risk. I don't think we can attain zero risk anywhere in industry. And that may sound terrible, but many of you probably drove here today, and that's probably the riskiest thing you'll do today when you consider putting people out on platforms and opening vessels. And I don't think we'll ever get to a zero risk in our lives, no matter whether we work on offshore or in an office. Each industry has data, but it's not shared. How do you? Everyone said, "Oh, REACH is going to solve our data problems because all the data will be put on the table, and we'll eventually have access to it." That may be true of the high volume chemicals, but not of the small volume. The small industries tend not to test their chemicals or their products, so we don't have data. I'm basically finished.